charger and 12-volt batteries. So what we're going to need, first of all, we're going to need the second thing we're going to need is this big transformer, and we're going to be using this rectifying diode. And this rectifying diode, this is a KBPC 3510 rectifying diode. And what the diode does is to convert the AC current into DC current. So first of all, we are going to connect the AC of our transformer, because the transformer consists of two parts, a secondary and a primary coil. So what we're going to do is to connect the AC part. We're going to be we're going to connect it to this. This is a 13 amp. And first of all, we just want to connect this part first, because this is where we're going to hook it up to our wall sockets. It is very important that when you're connecting an AC line, you use your tape to tape it up, to insulate it so that you don't get shocked. So just tape it up. Oh, thank you, Ruth Ashoton. Thank you so much for your support. Hope you're doing great. So we are going to tape it up, and it's best to tape it very well so that it should be insulated. So we are going to tape the other parts, which is very important. Okay. Oh, I'm glad you're doing great. Good. So we finally taped the two parts. So it is being connected to this, so that later on we'll be connecting these to the wall sockets. So we've connected the AC line, which is this. So this is where it's going to convert the current from AC to DC. So this side, we're going to be hooking it up to a rectifying diode. Oh, thank you very much, Ruth Ashoto. I'm doing very fine. So we're going to be connecting the other side to this rectifying diode. This is a KBPC 3510 rectifying diode. And what it does is to rectify the current, convert it from AC to DC. So this rectifying diode has 4 pins. AC line is going to go to the 2 pins right here diagonally, and the other one right here, we have if you look at it, it's labeled there. We have the positive and we have the negative. And this side, this is the sign for alternating current. This one is also for alternating current. So now let's do the connection. I have one that has already been wired up. The side we're connecting right now is going to be for the AC line connected to the transformer. And I'm using a white wire. I hope you guys can see it clearly. I'm using a white wire for it. Good. And now I'm going to be connecting the second one, okay? So what I did was to use white wires for both of them. So that it will be easy to that these are for the AC line, which will be connected to the transformer. Okay, good. So if you look at it right now, these wires right now, which is connected diagonally, they are both for the AC line, And this is going to be for the negative, and this one is going to be for the positive. So now what we're going to do now is to connect this wire, which will be connecting to the AC line. We're going to try to connect it to this part here, AC current, and the diode is going to convert that current into DC. So we're going to try to tape it up. It is always best to insulate it. It is always best to try to insulate it, because we are dealing with AC current. Whenever you're dealing with AC or DC current, it is always best to tape it up, because so that they don't get bridged together. Because what we want to prevent is causing any hazard. Good. Now that they are insulated, if you take a look at it, you can see they are insulated, which is better. So these two you're seeing right here, this is for the negative, this is for the positive. So right now, what we're going to do is to connect the last piece, which is the capacitor. So now, guys, if you take a look at this capacitor, you can see it is written boldly on it, 220 volts AC at 220 microfarad. So this 200 volts means that's the maximum voltage this capacitor can hold. It can take up to maximum 200 volts DC. That is the maximum power, maximum voltage it can hold. Anything that is more than 200 voltage is going to blow up the capacitor. So I'm going to be connecting the positive side to the positive wire right here. But first of all, before I do that, I'm going to hook it up to our extension, which has power right now. If you look at our extension, you see there's light right there. That's live power coming out from it. So what I'm going to do right now is to connect these AC parts to to the extension. I don't know if you can see it. Let me bring it closer. Okay, so we're going to connect it. So it's connected right now. It's connected right now. So there should be current right here. So one way we're going to know is to touch it this way. I think there's a spark. You can see it. Or you can use your multimeter, because this is 12 volts. So we're going to turn the multimeter to the other direction, and we're going to use our multimeter to test the voltage. So just bear with me. Remember, the blue is positive and the brown is negative. So you can see the multimeter turning to the right hand side. That shows this current. So we have about 12 volt current right now. So what this transformer did was to convert the current from 220 volts, which is coming from this extension, to 12 volts AC, which is this line right here. So 12 volts AC is now converted into DC. So with the help of this transformer, it's going to help to with this capacitor, it's going to help to smoothen the current. So we're going to connect this capacitor to the diode, to the positive side of the diode, and we're going to connect the other side to the negative side of the diode. So if you look at it closely, you will see this is our positive and this is our negative. And if you bring them together, you see there is a small spark. You can see it. That shows the capacitor is even giving it more power. So what we're going to do right now, we are going to test there are some things we are going to test right now. We're going to test like like this PC fan. And this PC fan is rated for, if you look at it closely, is rated for 12 volts at 0.15 amp. We can use it to test it to see how well it's going to work. You can see it blowing. It's really blowing very high right now. I don't know if you can hear the sound, but it's really blowing very high right now. So we finally converted the current from AC to DC. So we're running at 12 volts right now. That's why we are able to power this PC fan. So with this setup right now, you can use it to power anything that is 12 volts. So we are going to try to connect this big DC motor. This one takes a lot of amperage to be able to run it. So what we're going to do, we are going to try to extend the wires. The wires, it's very, very short. So what we're going to do first of all is to bring out the positive side out. So the positive wire is connected, and we're going to use this one for the negative. Depending on the color code you want to use, you can decide which one works for you best. But most times it is better you use the standard color code, which is red and black, so that you don't mix it up. So now we're going to connect this this DC motor. This one takes a lot of amperage, and let's test it to see how it's going to work. Okay. It's struggling to carry this one. Okay. The amperage of this DC motor is very high. It's still struggling to power it. Though when I tested it off camera before and it was really working. But we're going to test other things for it to work. Like, remember I tested this one, and this one is running very, very well. Anything 12 volts will run perfectly well on it. And we can also test like this motor, like this small DC motor. It's still going to run very well because we are running on 12 volts power right now. You can see how fast it's running. I don't know if you can hear the sound. It's running very high. You can see it. So you can use this power to power anything 12 volts. You can see how fast it's running. That shows the current is very high. Good. So the aim of making this to be able to charge 12 volt batteries. What we just need is just a transformer, a rectifying diode which converts the current from AC to DC, and we have a capacitor right here. So the capacitor is meant to increase the voltage and to also smoothen the output voltage, which will be coming from the rectification of this rectifying diode. So what we're going to do, we are going to try to connect this is a 12 volt battery. I don't know if it's showing that it's very big. So this is a 12 volt battery. I have a 12 volt battery right here, and this is a homemade battery. So let's put it right there. It has a positive and a negative, so we can just hook it up to it, and you can see the negative very big, and the positive clamp. So once you hook it up to it, it will start charging. With that, we can be able to charge our battery. We can charge it full. So guys, this is how you make a 12-volt charger. It's just very simple, nothing much, nothing fancy, just a big transformer, a rectifying diode, and a capacitor will be able to make you to charge anything that is 12 volts power. So guys, thank you so much for tuning into my live today. I really appreciate the support. So later on, I'm going to be giving you out, I'm going to dish out so many informations of how to do battery charger that has an automatic cutoff. That's when you add other things like relay and other components. It will help to be able to sense the battery. When the battery is filled up, it's going to stop charging, which is even better. So guys, thank you so much. I really appreciate you guys for tuning in, and I will see you on the next live or on the next upload. Bye. Take care. Love you guys.